Hi everyone. Today I'm going to be talking about acceleration for a little bit, and then I'll introduce free falling and acceleration due to Earth. So first and foremost, I would like to tell you that acceleration, not to tell you, but just reviewing things. Acceleration is change in velocity over some time. So change is v2 minus v1. That's, you already know. Change means the difference between first and last over time. But let's talk about an example and the answers that we end up with for acceleration, and then I elaborate on the meaning of acceleration in real life. Suppose I'm going by 5 meters per second, so that is my v1, and then I increase my velocity to, let's say, v2 of about 15 meters per second, and let's say I do this, I basically change the velocity over 10 seconds, okay? Now my acceleration is v2 minus v1 over t, which is 15 minus 5 over 10. That gives me 1 meters per second squared. And in the other video, in the previous videos, I already worked out how we get meters per second squared, or how we get the unit for acceleration. But let's recall our previous exercise. So acceleration is change in velocity over time. Velocity has a unit of meters per second, and time has units of second. Okay? Now, give this a factor of 1 and work out the complex fraction. Meters times 1 gives you meters. Seconds times seconds gives you seconds squared. Now, it could be the case where your velocity was miles per hour, right? And then you would think about hours all the time rather than seconds. Then acceleration becomes miles. If v is in terms of miles per hour, acceleration would be miles per hour squared. Again, why? Because acceleration is essentially velocity over time, which is miles an hour, over time, which is another hour. Miles over hours times hours gives you hours squared. So you basically, in general, you always have squared for your time, a unit of time for your acceleration. Why? Again, because there is meters per second, or meters or miles or kilometers per hour for the velocity up there. There is another time unit down here, so that gives it a power of 2. So that's about it. But what it means when we say acceleration of this motion is 1 meters per second squared. What we mean by that is that if I start off by 5 meters per second, in every single unit of time, I'm increasing. Here, increasing, sometimes you're decreasing your velocity, but here I'm going from 5 to 15, and in every single unit of time, here the unit of time is seconds, in every single second I'm increasing, I'm earning more speed by 1 meters per second of speed. So you are starting off by 5 meters per second. After 1 second, you earn 1 meters per second and add it to this, because you have to change your velocity, and that's why you have acceleration, because acceleration is change in velocity. After 1 second, it becomes 6 meters per second. After another second, add another one, becomes 7 meters per second. You do this for 10 seconds, and in the end, you end up with a velocity of 15 minutes per second. Okay? So acceleration of any number tells you in that unit of time, now here is seconds, I could give you acceleration in miles per hour squared. The unit of time there would be hours. In every single unit of time, you are increasing your velocity by this number. If this is 1, you're increasing by 1. Your velocity, it gets increased by 1. If I would end up with acceleration of 2, then 5 would be 7 after 1 second, after another second would be 9, then I would change my 5, the first velocity, after every single second by 2 if this acceleration would be 2. Okay? So now, due to the fact that we live on Earth and due to the fact that Earth is a huge, gigantic, gigantic ball of mass, it attracts all the objects that are not on Earth, that are like they're at some height with respect to the Earth. And as you already know, so here is Earth. Due to this guy, all the objects that are having some height with respect to the ground are pulled down by Earth. And this happens everywhere on Earth. Okay? It's just not the States that we're experiencing it. It happens everywhere on Earth. Now, as you already know, if I just release this from velocity of 0, it earns some speed as it drops on the board. Or if you just release a ball from a top of a building or something, it gains speed, and then once it gets down the building, it just crashes. Okay, this means that the velocity of the falling object is changing, which means that it is accelerating, because acceleration always is directed to change in speed. Okay, so due to Earth, we have an acceleration of roughly 10 meters per second squared. This means roughly, it's not exactly. 10 meters per second squared. Because this is a very special number for us, we give this a different sign. We call this a G. G for Earth is 10 meters per second squared. And I just told you what this number of acceleration means is that it means at every single second, at every single unit of time, the velocity of a falling object is increased by 10 meters per second. Let's say I'm dropping it down from velocity of 0. This, after 1 second, earns a velocity of 10 meters per second. The second after that becomes 20 meters per second. Another second becomes 30 meters per second till it hits the ground. Okay? So this way you can actually estimate and measure indeed velocity of objects when they fall down, if you know how many seconds it takes for them to fall down, for example, a height. Let's say I have a building here. Here's the building, and there is a ball that drops down from the building. Okay? Let's suppose that I'm releasing this ball, and releasing means, I just release it, right? The velocity, the first velocity is dead 0. And then let's think, let's suppose that this gets here after 6 seconds. Now I ask you, what is the velocity once it reaches the ground, when it hits the ground? 0 after 1 second becomes 10, after another second becomes 20, after another second becomes 30, another second 40, another second 50, and I told you 6 seconds. So when it hits the ground after 6 seconds, the velocity becomes 60 meters per second.